Okay, physics friends, here we are today. We're going to do a basic conservation of momentum problem. And in this problem that I have set up, I have two folks on ice skates. You can see my little ice skates that I drew there. And the first person here is holding on to a snowball, and that snowball has a mass of 0.045 kilograms. And this person's going to throw the ball with a speed of 30 meters per second. The first person and the snowball are initially moving with a speed of 2.5 meters per second, and they're going to throw it at the second person here, who's initially at rest. So then the throw happens, and the question is after the second person catches the snowball, what are the new speeds of each person? Okay? So we're going to look at the conservation of momentum for both people. So we're going to look at the thrower first, and then the person who catches the snowball second. Okay? So if we remember, momentum, or P, is equal to an object's mass times its velocity, and that the total momentum of an object or a system before the action happens, or the impulse happens, has to equal the momentum afterwards. So if we keep that in mind, let's look at the first person, this guy here, this person here. Okay. So the snowball and the person are together. They are one object. So they have a combined mass. So that momentum, to begin with, is a combined mass of the mass of the thrower plus the mass of the snowball. And they are moving together with the same initial speed of 2.5 meters per second. But then after the throw is done, I have the individual thrower's mass plus their new speed, and then after he let go, the snowball was a separate object. So it has its own momentum, so that would be the mass of the snowball plus the final speed of the snowball. Okay. And so in this case I have, let's see, the mass of the thrower, let's say it's 65 kilograms. 65 kilograms plus the 0.045, and their initial speed together is 2.5 meters per second. And then afterwards, the mass of the thrower is still the same, 65, and his new final speed is what I'm looking for. Plus, though, the momentum of the snowball. And so that's the 0.045 kilograms, and the speed of the snowball after the throw is 30 meters per second. So when I do my math and I solve here, I get 65.045 times 2.5. That's going to give me 162.6, and this is 65 VF, plus 0.045 times 30 is 1.35. So 162.6 minus 1.35 is 161.25, and that's going to equal 65 times the V final. So I'm going to divide by 65, and that's going to give me the new speed, or the final speed of the thrower. And you come up with 2.48 meters per second. And it's in the same direction that he was initially moving in. Okay. So the second person, this person over here, let's look at their final speed. So let's give this person a mass of 60 kilograms. Okay. So initially, this person is solo. He's not holding on to or she's not holding on to the snowball. So they only have their own momentum, or their own mass, the mass of the catcher, times the velocity initial. Okay. But at the end, over here, after the throw, this person, the 60 kilogram person, they catch the snowball. And so they are now the mass of the catcher plus the mass of the snowball times the final velocity of them combined. But before they catch it, there's still some other momentum that's happening within this system, and that's the snowball, because the snowball's in motion. Okay? So I have to have that momentum of the snowball at my beginning. I forgot to put that in there. So that's going to be the mass of the snowball plus the speed of the snowball initially before it's caught. Okay? So there's my conservation of momentum equation. And so this is going to be 0.045, I'm sorry, not a plus there, that's a multiplication sign, times 30, because that's the speed the snowball was thrown, plus the mass of the catcher, which is 60 kilograms, and its initial speed is 0. Ah, that's nice, this whole piece can go away. And that's going to equal the mass of the catcher, which is 60 kilograms, plus 0.045 kilograms of the snowball, and I want to know what their combined speed is at the end. Okay? So I've already done this calculation up here, 0.045 times 30, that's 1.35. So this is 1.35 equals 60.045 VF. And so 1.35 divided by 60.045 is a final speed of 0.0225 meters per second. Okay. What direction is that in? That's a good question. Is it going to be in the positive direction, what I've said that this person is moving in, or will they move this way? So the correct answer should be positive, because it's moving in the same direction as this guy. Okay. So now let's add a little bit more fun here, because we can do a couple things with this. What if I say that the coefficient of friction between the ice and the skates is 0.005? How far will the skater move after catching the snowball? How far will the skater move after catching the snowball? Okay, well, how far will he move? I'm looking for a distance. So my brain thinks there's a couple ways I can find distance. One is kinematics. I have an initial velocity. Here it is. A final velocity, well, they're going to come to rest. I have that. Do I have a time? No. Do I have an acceleration? No. Maybe kinematics isn't the right way. How else can I find distance? Well, work. Work, remember, that's a force applied over a distance. And what would my force be that's slowing this person down? Well, that would be friction, because it's telling me it has a coefficient of friction. So using energy is the way to go. Okay? So the snowball and the catcher together, they have this kinetic energy. And then friction is going to do work, so it's minus work, and then they're going to come to rest. So that's going to equal 0. So this ends up being 1/2 mv squared minus the force of friction times the distance, and that's what I want, and that equals 0. And because both of these, they equal 0, I can move the friction times d to the other side and not have to worry about this negative. So I get 1/2 mv initial squared equals mu, and because we're perpendicular to the surface, Fn is equal to mg. So this is mu mgd, and I want to solve for d. I want to know how far they're going to go. So I'm going to divide by mu mg. And if I divide by mu mg, what magical thing happens with the m's? They divide out and I don't need them. So my distance that this person with the snowball is going to travel is v initial squared divided by 2 ug. And so that would be 0.0225 squared divided by 2 times 0.005 times 9.8. And when I do that calculation, I end up with a d of 0.005 meters. That would also be 5 millimeters. So not very far, clearly. The snowball didn't impart that much of a force on the skater to move it, but it does move them a little bit farther. Okay? So you could use energy to find how far a person would go, or you could use kinematics. It depends on what information the problem gives you. And then you could do some other things. You could determine the acceleration that the object experiences. There's lots of places you could go from here. So see how it works for you. Hope it helps.